Hello, welcome to In 5 Minutes. Now from all the DC analysis of the transistor we have done with the AC model of the transistor. What you can see in the first diagram is you have pure AC voltage applied. So you have pure AC current IB, pure AC current IC and pure AC voltage VCE. What we are considering here is only the transistor. We are considering only the transistor and no other resistance, capacitance, voltage sources connected to the transistor. So what we are going to do, we are going to model only this part of the circuit, that is we are going to model the transistor over here. So what you can say, it is which type of transistor, N or P. Arrow is always from P to N, so it is NPN transistor. How many port device? This is input port, this is output port, so it is 2 port device. So what we are going to do, we are going to convert it into an model, the transistor into an AC model. That means whenever you have AC signal, how to analyze the entire circuit. What you can see over here is nothing but VBE IB, that means input voltage versus input current. So which type of characteristics? It is nothing but input characteristics. What you have on x-axis, small I suffix capital B, that means it includes DC plus AC values. What you can see at Q point, the graph is base current versus the base emitter voltage and with a small time varying signal superimposed at the Q point. This is time varying signal superimposed at the Q point. Now what you can say, since these sinusoidal signals are of small value, that means peak to peak amplitude is small, so we are calling it as small signal, sinusoidal signal. Now what you can find the slope. How we are writing the equation for slope? It is nothing but y by x, which is m. For 2 points, what we are considering, y2 minus y1 upon x2 minus x1 equals to your slope. Now what I am considering, on y axis you have current IB, so you can write it as change in IB for change in VBE, that is y2 minus y1 upon x2 minus x1. Now what you can see here, it is written as I suffix capital B. Here I am considering pure AC signal, pure AC current and pure AC voltage, right? So it is written over here considering the pure AC. For pure AC you can find the slope in this way. Now what you can say, for pure AC, small signal sinusoidal, we are applying as the input. So sinusoidal signals are of small value, so we can treat the slope as a straight line. That means the slope is assumed to be a straight line. So what you can consider, you can consider one value of IB and only one value of VBE. So you can find 1 upon R pi. The slope is nothing but 1 upon the resistance, right? It is 1 upon resistance because it is current upon voltage, so it is 1 upon resistance. So we can find VB as IB into R pi, right? Now what you can say here, R pi is change in IB for change in VBE. Now here we are considering which values? At Q point we are considering AC plus DC value. In previous case we had considered only the AC value and AC signal was small, so we had directly find the slope. In this case we need to do the analysis. Now you know the equation for IC. In the collector current, when I have explained, I have derived the equation for IC as IS e raised to VBE upon VT. Now what is the relation between collector current and base current? Your IB is IC by beta. So what I can do in this equation, if I want to use IB, what I need to do, I need to divide this by beta, so I can get the equation for IB. So if I want IB, what I will write in the equation, this is equal to change with respect to VBE. I have the equation for IB as IS upon beta e raised to VBE by VT. Now we are finding this at which point? We are doing this analysis at Q point, right?